In 400 kV and above voltage system, there exist two DC, one DC for main 1 protection and trip coil 1 for circuit breaker, and another DC for main 2 protection and trip coil 2 of the circuit breaker. Because if any DC fail, the circuit must be tripped on fault via other DC. That is why two separate DC and two separate charger is used in voltage class of 400 kV and above voltage system in a substation. Friends, today I will discuss about double DC system and impact of DC earth fault in case of double DC system. In this diagram, the double DC source has been shown. Here there exists one DC via J11 and J12. This DC1 source is taken via MCB 11, and after the MCB it is taken to the main 1 protection and trip circuit 1 of the circuit breaker. Also, we use a DC supervision relay as 80 DC1 to monitor the DC system, whether DC system is okay or not. If DC is not healthy or MCB is tripped, then annunciation will be go through the annunciator to alarm as DC1 faulty. Again, the DC source 2 is taken from the DCDB as J21 and J22. After MCB 21, it is taken to the main 2 protection and trip circuit 2 of the circuit breaker. Again, there exists a DC supervision relay, that is 80 DC2, to monitor the health of the DC, whether if DC is available in all the time. If DC is not available, then annunciation will come to the annunciator when DC as DC2 is faulty. In the right hand side, there exists a DC selector switch. Via this selector switch, we can change from DC1 to DC2 source as shown in this diagram. The function of the selector switch will be discussed later on. Here you can see the J15 and J16, that is after the selection of the DC selector switch has been taken to the isolator circuit, synchronous circuit, and also the metering circuit and CB travel circuit. And the DC after selection of the, that is J25 and J26 is taken for the indication circuit, and before the selection, that is J13 and J14 is taken to the main 1 protection and the TC1 circuit of the circuit breaker, and J23 and 24, that is from the DC source 2, is taken to the main 2 distance protection and TC2 trip circuit 2 of the circuit breaker. Here the selector switch for DC selection has been shown in this diagram. Here after the selection, there exist two output, that is J15 and J16, and another is J25 and J26. Here how the DC selection is taken, and there exists separate contact for source 1, that is 1P1 and 1P2 is source 1 contact, and 2P1 and 2P2 is source 1 contact, 2P3 and 2P4 is source 2 contact, and 3P1 and 3P2 is source 1 contact, 3 and 3P4 is the source 2 contact, and 4P1 and 4P2 is the independent as well as source 2 contact, and 4P3 and 4P4 is the independent as well as source 2 contact. 5P1 and 5P2 is source 1 as well as independent contact, and 5P3 and 5P4 is the source 1 and independent contact. If you select in the source 1, then only DC source 1 will be selected in the output section. If you put the switch in independent position, then source 1 and source 2 selection will be taken as per this diagram, that is J15 and J16 will be coming from DC1 source, and J25 and J26 will be coming from DC2 source, and for source 2 contact only there will be source 2 input. Now whenever we put the DC selector switch in source 1 position, how the source 1 is selected has been shown in this diagram. J15 and J16 will take the source 1 input via 5P1 and 5P2 and 5P3 and 5P4, and J25 and J26 will take the source 1 input via 1P1 and 1P2 and 2P1 and 2P2 as shown in this diagram. When the selector switch is in independent position, then J15 and J16 will be taken the source 1 input via 5P1 and 5P2 and 5P3 and 5P4 contact, and J25 and J26 will take the DC2 input via 4P1 and 4P2 and 4P3 and 4P4 contact. Again, if the DC selector switch is put on position source 2, then J15 and J16 will select the DC2 source via 2P3 and 2P4 and 3P3 and 3P4, and J25 and J26 also select the DC2 source input via 4P1 and 4P2 and 4P3 and 4P4. Now whenever the DC is connected to the charger, and in the DC for a healthy system, that is positive to earth voltage comes to 120 volt and negative to earth voltage comes to minus 120 volt. This will be true for both the DC system in the 400 kV and above voltage system. Now in the source 1, that is in DC1, if a positive to earth fault occur, if it is a solid positive to earth fault, then voltage between positive to earth comes to 0 volt and negative to earth comes to minus 240 volt. Similarly, if a negative to earth fault occur in the DC2 source system, if it is a solid negative to earth fault, then positive to earth voltage comes to 240 volt and negative to earth voltage comes to 0 volt. Now in the main one distance relay, DC1 source is supply for auxiliary supply as J11 and J12. And similarly in the main two distance relay, J21 and J22 is the auxiliary supply for main two distance relay. Now for a DC mismatch, and coincidentally the positive to earth fault in DC1 and negative to earth fault for DC2, what is the impact? We'll discuss now. Now by means of multimeter, if you measure the voltage between for DC1 J11 and J12, it will comes as 240 volt, and between J21 and J22 it will comes as again 240 volt. But if you connect the voltage in between J21 and J12, that is positive of DC2 and negative of DC1, if there exists a DC mismatch, that is the negative of DC is mismatched with the negative of DC1, then the voltage between these two terminal will comes to 480 volt via earth, and this will lead to a dangerous overvoltage, and this overvoltage may burn the relay auxiliary contact and also burn the relay. So mixing of either of DC positive or DC negative, The auxiliary voltage supply between the two terminals comes to 480 volt, which results as relay to be burnt out.